Now we're going to use another technique to indirectly measure height, and that is actually using mirrors, which are actually used quite a bit. So, how do mirrors work? Well, if I were looking at this building here and pretend your person is here on the first side, this AB here, and their eye level is at point B. So we're going to pretend they're 6 feet tall or their eyes are 6 feet up. Obviously, it's not me. And we place a mirror kind of close to a building, right? We're trying to measure the height of the building. Well, the closer I put the mirror to the building, the lower you're going to see on the building. Why is that? Well, the light that's bouncing off of the building will be coming back to hit the mirror and come off the angles. And whatever hits the mirror at the same angle as goes from the mirror to the eye, that's what you're going to see in your eye. So the interesting thing is that these two angles, you notice that no matter where I put the mirror, those two angles match. All right, you got 23.98 degrees and 21.43. So as I move the mirror, you can see that the sight line is moving up the side of the building. In fact, I can keep moving the mirror until it just matches. Let's get that to match. And you'll see that the ratios of the height to the distance to the mirror for both triangles are the same. And we also know that all three angles are the same. So these are similar triangles. So when I ask you which ratio is bigger of the height to the distance to the mirror, well, it says height to shadow, but it's really height to distance to the mirror, they're both the same. Okay. So how do we solve these proportions? We're going to draw a picture and set up a proportion with two equivalent ratios just like before. Except instead of doing height to shadow, you're doing height to distance to mirror. So you'll have it for one object, that's the left side of the equation, and then you'll have it for the right side of the equation, the second object. So in our example, Ayana has to measure the height of hallway D from the courtyard. And how tall is hallway D? So I have all the information. I'm going to redraw it as a picture, and so I took the words out, and I'm putting all the words into a picture. So you can see that she has the mirror is 12 meters from the wall, and she steps back a little bit more, 2.25 meters, and her eyeball height is 1.5 meters up. And when she's that far away, she can sight the top of the building. So that means we have similar triangles. X is to 1.5 as 12 is to 2.5. Or you can even say X is to 12 as 1.5 is to 2.5. And in fact, that's how I set up my ratios. Height to shadow equals height to shadow. Now I'm going to go ahead and cross multiply, which is basically the shortcut for getting a common denominator, and then setting numerators equal. And I get 2.25x equals 18. I want to solve for x, so I divide by the coefficient, 2.25, and I get x is 8 meters. So that means that the building is 8 meters tall. So to reflect, what do you notice about the angle made at the mirror between the ground and the line of sight? And which are congruent for both triangles? Is it the corresponding angles, the corresponding sides, both, or neither?